back to the good old days again. Good day, everybody, and welcome to another week of e-learning. And so we're kind of to the midway point in this last week of April, and so we have a lot of things to get through today. Mondays in class, remember, used to be very busy. We had a lot of papers to pass back. Well, we're not passing papers back, but we are going to have regular old logic problems this week that I'm going to give you hints to, and we have a couple opportunities for competitions. One is we are in the final four, and we'll get you a finalized date on that. But if you look, we made it to the final bracket, and we made it through round 1, round 2, round 3, round 4, and then there were 4. And you notice that one of the teams left in the 4. I don't know if they entered twice and split their team in half, but there's 2 of them, and so I don't quite know how that works. Hopefully it's all above board, but we'll see. And so make sure that we're ready for that. And so it might be this Friday. We'll let you know. And then also we have, if you look, there's going to be an academic Super Bowl competition that's going to be individual. And so if you would like to take that, if you click on the link, it will lead you to the syllabus of everything we were supposed to cover. Now, we've covered a lot of these things. Probability was 50%, but then exponential functions, we never got a chance to practice those and to review those. And so if you want to, you can go on Khan Academy, and you'd have to look under Algebra 2 and go to exponential models. And also there's one called, now I lost it, but exponential models, and then figuring out what this constant E is. And exponential models here, and then more exponential models here on how to construct exponential functions. And so rational exponents and exponential functions. And so just look at the syllabus here, and then I will give you more information on Wednesday. I think we can start taking it individually. It'll be a Google form. I think it'll be 30 questions. I think you'll have around 40 minutes. You can use a calculator. And then the last thing is on the academic Super Bowl competition is functions. Identifying if it is a function, if it passes the vertical line test. One-to-one functions we don't talk about too much in Algebra 1, but those are the functions that are a function and the inverse is a function. So not only does it have to pass the vertical line test, it has to pass the horizontal line test. And so knowing what the domain and range is, parallel and perpendicular lines, slopes, y-intercepts from data, and function notation. And so we should feel good about this stuff. Even pre-algebra, we're starting to cover this. And then the probability things, the only one we would be, oh, there's Kaya. Hello, how are you? And so the only one we'd be a little shaky on is the exponential function. So if you're serious about taking this, you might want to brush up on that, and I'll get you more information and get you the link. And so I did know, I got an email that when we do compete, you want to pick Northridge Middle School of Middlebury, Indiana, because there is another Northridge Middle School maybe in Crawfordsville. And so you might have to ask Lincoln and Kirsten about that, Crawford. But otherwise, we'll pick Northridge Middle School of Middlebury, and we should be good. So that's coming up this week. And we have a good chance of doing really well because I see Discovery didn't sign up. So we can get this. And so make sure we'll participate. And so let me know about that. And so we have that. We have the 2 competitions. Make sure you take attendance. Most of you are. You need to get into a routine. And so I get up, I do certain things in order. I see some of your routines like 10 o'clock at night or sending me homework at 12:02 a.m. And so not a good routine. Good routine. Get up, get these things done, get dressed up, and I'm ready to go. And so get into a routine. We have several more weeks of this. 5 more weeks. 5 more weeks at 12 a.m. is not good. And so we need to make sure we have that. Email me. Let me know. I'm going to get grades in the Power School. And so we want to get all that done. And so make sure you let me know if you need anything. So you will notice this week whether geometry, algebra, pre-algebra, we got logic problems number 31, and we want to give you some hints on these. And so just like good old days, and where I used to stand and teach, much better than the sitting and teaching, too much sitting around. And so on the logic problems this week, the first ones, you're only allowed to use these numbers, a 50, a 20, a 10, a 5, a 2, and a 1, all of which used to be denominations of coins. For all of you numismatists out there, there was a 2-cent piece and a 20-cent piece. In fact, the 2-cent piece was the very first coin to ever say "In God We Trust" on it during the American Civil War. I think it was 1864. And so, but you can only use these 6 numbers, and you can use them as many times as you want. And you got to get the rows and columns to add up to the numbers I gave you. So if I say this row adds up to 110, you can only use 50s, 20s, 10s, 5s, 2s, and 1s. If this column adds up to 111, this column adds up to 13. And then we need to know where we're going to place these. Well, first of all, if you're going to use all 20s, 20, 40, 60, 80, you wouldn't get to 110. So you need a 50. And if I put a 50 here, you know the 50 can't go in the 13 column or the 11 column. It could go in the 82 column. But look, if I did 50, this would be 20, 40, 60, and that'd be 110. But you can't even use 20s in these columns. So that means I'm going to need another 50 right here. And I know those are both 50s. Well, if that's a 50 and the other one's a 50, I need to get to 10. Well, the one way to get to 10 is 5 and 5. Can't do 10 and 1, can't do 2 and 2, so pretty much this is going to be 5 and 5. And I know this right away. Then, if I go 13 here or 11 here, that means these 3 have to add up to 6. And that means the other ones have to add up to 8. Those are adding up to 6. These are adding up to 8. And so, but I'm going this way, and I'm adding up to 6. Well, I know in this column right here, to get to 6, you can't do 5 and 1 because you can't use zeros. And so the only way to get to 6 would be 2, 4, 5, 6. 2, 2, 1, 1. Of course, I don't know the order of this. Now, to get to 77, 20, 40, 60, see, I need a 50 in this. And the only column that could have a 50 is this one right here. Would have to have a 50. And then the rest of this would add up to 27. Well, to get to 27, it'd be a 20, a 5, and a 2. We can't have a 20 in this column, and you can't have a 20 in this column, so the 20 is going to have to go here. And then this is either going to be 5, 2, or 2, 5. Well, it can't be a 5 here because you'd have to have more than 1, so this would be a 2, and this would be a 5. And then here I need a 12, because I already got 70, and I need a 12. Well, I can't put a 10 here, so the 10 would have to go here. And then this would be a 2. Well, then, if I got a 10 here, then this is a 14. Well, how in the world are you going to get a 14? Well, that'd be a 10, 2, and 2. Well, you can't put the 10s in these columns because this would add up to too much. So this would be a 10. And then this is 50, 100, 110. There's my 1. 10, 12, 13, 5, 7, 9, 11, and I'm done. And I just did one for you. You write it down. You send it in. I even said due Saturday. Some of you are like, when exactly are the logic problems due? They're due at the end of the week. If you send them too late in the weekend, I won't get them in the Power School maybe for another whole week because we'll get the grades in. I have a bunch of grades I've graded, but I need to put them in Power School, which is going to happen after all these videos are made and answering your emails. And so if you don't get them in soon or right away, it might not make the first cut. And then it sits in the pile till it gets into the second cut. And so the best thing to do is get stuff in as soon as you can. Okay, so you have 3 more of those. And then down here, I have 2 more questions for you. One is you're using the numbers 1 to 20, each of them once. Most of these squares are going to be empty. On this one, you're only filling 2 squares in each row and column. And so these things are going to be mainly empty. There'll be 2 in every column, and there'll be 2 in every row. Now, how do I know which ones? We are going to write the numbers 1 to 20. I should have typed them out, and then you could cross them off as you used them. But you could do that. You could just write 1, 2, 3, 4, 5, all the way to 20. And you want to cross them off as you use them. And so this is called product pairs. Give me a pair of numbers, and I'm going to get each of these. Well, some of them have more than once, like 48 could be 6 and 8. It could be 12 and 4. It could be 16 and 3. All those are under 20. So you don't start there. You pick a number like 15. Well, that'd be 1 and 15 or 3 and 5. Still too many possibilities. But then here, this is 11 times 12. And that's the only possibility. 170 is 17 times 10. That is the only possibility. Ooh, 17. You know, a lot of numbers 17 doesn't go into. And so when I look down here, wait, this 34 is 17 times 2. So then I know the 17 goes right here, because it goes into 170 and it goes into 34. When I look down here, let's look for 11. Does 11 go into 48? No, 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 yes. So 11 goes right here for the 209. Well, 11 goes into this how many times? It goes in 19 times. Well, which one of these numbers does 19 go into? 48? No. So then I know there's no number here. Does a 19 go into 28? No. Does 19 go into 52? No. Does 19 go into 133? 19 times 7. I think. Yeah, and so that'd be a 19. And then you know the rest of this column is empty, because you have your 19, your 11. And you could circle the 19 and the 11. And then you figure out where the 7 goes. 7 go into 34? No. 48? No. 60? No. 105? Yes. 7 times 15. 7 go into 90? No. 7 go into this? Yes. 7 goes into this 4 times. But can we use a 24? No. And does 7 go into... No, so you know the 7's right here. 7 times 19. And I better stop before I make a mistake and somebody email. You gave the wrong hint on the logic problems. And then you'd cross off this whole column. Okay? Then, for the very last one, we'll move myself to the other corner. Whoa. Maybe we'll move up here. And it says, outline the greatest number of squares of any size such that the edges do not touch. And there's lots of squares here. And then you got to count them. And I got to be able to see it when you scan it. So for example, you can't outline this square and then outline this one, because those touch. And so if you're going to outline this one, you can outline this one because those don't touch. But then this one touches this one, so then you wouldn't be able to use that one. But if you don't use that one, you could use this one. But it says the squares cannot even touch at a single point. What is the maximum number of squares that you can get? Because sometimes picking a square outlines. Now this square is fine, and then picking this one. Because even though it's inside, they don't touch. The edges do not touch, not even at a single point. So you need to find the maximum number of squares. Show them and write it right here to get all the points. Okay? So we got logic problems this week. We got those competitions coming up. And so make sure you print these off. You can send them to me at the end of the week. And so just trying to get back to the regular old logic problems. And so we're going to get to that. And then time to start the notes. Okay? Just like back in class, we got lots to do. And the sun's coming up and we got lots. Okay? So let's go back to our agenda for today. Okay? And see what we have in store. What we have in store for algebra today. And so make sure you keep sending the assignments. And so we're going to still be on fractional, but algebraic fractions, but we are now going to be talking about solving equations for a couple days, and then we'll do some story problems on Friday. And so tonight's homework is page 299, 3 to 33 multiples of 3, just 11 problems. And so we want to give you some notes on that first, and then we'll talk about that. And so this is notes number 119, I believe. And so yes, no. Notes 118. And so if you mess up on the notes numbers and things, we'll get all that fixed when you send them in. And so we're going to talk about how to solve these equations a couple of ways. And one way is pretending there goes Kaya. Another way is pretending that you never watched the video. And if you never watched the video, you would just say, well, I have two n's here, I have 1/3 n here, and I have 1/4 n here. And so I would just add these up. And so one method is just do the problem. You just do it with all the fractions, which is yucky. Because if I had, what's 2 plus 1/3? Well, that'd be 2 1/3. And then we don't like mixed numbers. So then 2 1/3 is 7/3 n. And if this is 7/3 n, and over here is 1/4 n, I want to get my n's to the same side, so then if they add, we subtract. And so we'll subtract 1/4 n from both sides. If you subtract 1/4 n from both sides, when you subtract fractions, what do you need, Jacob? Common denominator. Very good. And what would that common denominator of 3 and 4, Elizabeth, be? Yes, it would be 12. And so off to the side or in our head, we'd have to do, what's 7/3 minus 1/4? Or Jack Long might just type it in his fancy, smancy Casio calculator and do 7/3 minus 1/4. But that would be 28/12 minus 3/12, which would be 25/12 n, which would equal 5. And then how would I get rid of the 25/12, Danielle? Yeah, multiply by the reciprocal. And so then we'd multiply by the reciprocal, and we would get 5 over 1 times 12 over 25. And that'd give you 60 over 25, but it'd be better if you just went, hoi-ya! And then canceled it. 5 goes into 25 5 times, and we would get an answer of 12/5. And so that would just be doing fractions. But there's a much easier way, and it's called clearing the fractions. Nobody liked them anyways. We just pretend to be their friend. And if you clear the fractions, you multiply by the least, that is an L, the least common denominator. And just to show you on this first problem, you already told us that the least common denominator was 12. So if I would take this problem and multiply both sides by 12, do unto one side as you do to the other, I would not have any more fractions. 12 times 2 would be 24. 12 divided by 3 would be 4. Over here, do unto one side as you do to the other. 12 divided by 4 is 3. And 12 times 5 is 60. And then over here, combine like terms, you get 28n equals 3n plus 60. And make sure, I usually say it correctly, sometimes the mouse. It's not my fault, the mouse made me do it. And write it wrong. And then if they add 3n, we subtract 3n, that gives me 25n equals 60. And then we divide by 25, and Mr. Nyson, look, you got a different answer. You must have made a mistake. Did I get a different answer? Is 60 over 25 different than 12 over 5? No, you just have to reduce this one. And so you divide by 5, and yes, you would still get 12/5. And so we want you to try clearing the fractions so we don't have them anymore. And so let's take a look at this next problem. What is the common denominator of 2, 3, 4, and 5? What is the least common multiple of 2, 3, 4, and 5? What do all those numbers go into? Colin? 60. That is correct. Was that the smallest one? 30? No, 4 doesn't go into 30. So it's going to be a 60. And so we're going to multiply this side by 60. That's why the Babylonians did base 60, because it had lots of factors. So then when you're distributing, you're not taking 60 times 2. You're taking half of 60, which is 30. And that's 30x. These problems are not good to do with a mouse. 60 divided by 3 is 20. 60 divided by 4, I believe, is 15, because you just take half of it twice. Half is 30, half is 15. Then 60 divided by 5 is 12. But here's the common mistake. Some of you will do all that perfect, but then you'll forget to take 60 times 17. And 60 times 17 is 112? 102, which one is it, Ryan? 60 times 17. See, I don't want to make mistakes. And it'd be 102, but then you got to add your 0. And so that'd be minus 1,020. And then that will equal, don't forget to do unto one side as you do to the other. And so that'd be 60x over here. And so here I got 30 plus 20 is 50. 65, that'd be what? 77x minus 1020 equals 60x. That is a 0. It's a 0. And then I'm going to move the x's over here. We're going to subtract them and get 17. We're going to move the 1020 to the right to make it positive. And then we're going to divide by 17. 1020 over 17. Does that give me a nice answer? Yeah, because we already multiplied it right here. We already knew. 17 goes into 1020. Why did I type that in? That felt dumb. And then my answer is 60. But don't think for a moment, well, my answer is always the common denominator. We never said that. So you don't say it either. Just happened to work out that way. Okay? So we got a couple more examples for you. Are you ready? You can always pause it. You can be like my daughter. If you think these YouTube videos are too long, you can listen to them at 1.5 speed, and then you can hear myself talk really fast. But then if I talk faster, then what is twice fast times 1.5? Well, then it'd be like 3 times as fast. Oh, no. And then if I talk 3 times as fast times 1.5, then how fast is that? Oh, my. So I'll talk normal speed and then stop rambling. This one, the common mistake is we are not going to distribute the negative. The common mistake in the next problem is we are not going to distribute the negative. You know how many times I see that on your homework? And so figure out what you're going to do wrong and then don't do it. The common denominator for 3 and 5 is going to be what, Dominic? 15, yes. And so I multiply this side by 15. And so here, don't actually distribute the 15. Just 15 divided by 3 is 5. And that's going to be 5 times y minus 1. I'm only giving you 11 problems. Minus 15 divided by 5 is 3. Then you can distribute the minus when you distribute the 3. You don't have to distribute everything in one step. Haste makes waste. And a stitch in time saves 9. And so 2 times 15 is 30. Then when we're going to whoop whoop and kiss our parentheses goodbye, we get 5y minus 15 minus 3y minus 3 equals 30. And so then that's going to give me 2y minus 8 equals 30. Then if they subtract 8, we're going to add 8. We can skip that step, but don't mess it up. 2y equals 38. And then divide by 2, and y is 19. The odd answers are in the back after you do the problem and check them. See, 19 minus 8, 19 minus 1 is 18, divided by 3 is 6. And then 19 plus 1 is 20, divided by 5 is 4. And 6 minus 4 is 2. So since it's on the video, I better check to make sure I'm doing them right. And sure enough, I did. So woohoo! We got this. Now, the common denominator here needs to be the common denominator of both sides. And so some of you will have trouble because you only find the common denominator of one side. The common denominator of both sides is 10, 2 times 5. And so when I distribute, 10 times 3 is 30. But then here, 10 divided by 2 is 5. And then it's 5 times this quantity. Oh, I forgot the x. Get the x back there. 11x minus 37. And then on this side, 5 times 10 is 50. Minus, and then 10 divided by 5 is 2. And we don't want to forget to distribute the negative when we distribute the 2. Okay? So I'm going to give you a second, get all that written down, and then get ready to distribute. Okay? So now we're ready to distribute. But notice we are distributing a negative 5, and we are going to be distributing a negative 2. We're distributing not a 5 and not a 2, but a negative 5 and a negative 2. And we want to see the steps. Don't you dare think you're just copying the problem, writing the answer, and then sending it to me and think you're getting credit. No, 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 no. And then, what is 37 times 5? Well, you could just multiply by 10 and then take half. 370, and then half of that is, what, 185? Yeah, it would have been easier just to multiply. And so, that would be 185, and a negative times a negative is positive. Then here we got 50 minus, and then negative 4x minus 12. And we show steps so we can see where we're making our mistakes. So 55 and 30 are 25 apart. That's negative 25x plus 185. Here, 50 minus 12 is 38. Minus 4x. And you can move the x's to the left, that'd make them negative. You can move them to the right, that would make it positive. If you added 25x, you'd get 21x. And here, if you subtract 38 from 185, you get, what, 147? Does that sound good? And this is divisible by 7. So if you divide by 21, you get 7. And x is 7. And let's go to the last one. And they aren't going to get any tougher than this today. And so if we go to the last one, oh my, right here. What is the common denominator of 8, 6, 4, and 3? What would it be, Jordan? 24. Excellent job. Since we already have parentheses, we're going to put brackets. We'll multiply by 4 factorial, which is 24. And then we're going to multiply this side by 24. Now it's like, okay, what things do I actually multiply by 24? Well, the numbers you're going to multiply, these are terms. There is a term here, a term here, a term here. This is a term, and then there. Right now, before we distribute. So what we're really doing is we're going to multiply 24 times the 2/3 times the 3/4, or the negative 3/4, times the negative 5/6, and then over here we're going to multiply the 24 by the 7 and the negative 3/8. And so that's what we're going to do. So 2/3 of 24, what would that be, Elijah? 16. Excellent job. 16 times x minus 8. Then what is 3/4 of 24? Cole? 18. Good job. And so that'd be times quantity 9 minus x. Then 5/6 of 24. What would that be, Bree? 20. That was good. And so that'd be 20 times x minus 11. And then here, we're just multiplying 7 times 24, which I believe is, what, 168? And then minus, what's 3/8 of 24? Cam? Yeah, 9, because 24 divided by 8 is 3, and 3 times 3 is 9. Now, what is going to be the common mistake that you people are going to make? Whoa, you think I'm going to make a mistake? Yeah, I'm not even there, and I know we are. It's distributing the negatives. Distributing the negatives and distributing the negatives. So if you know you're going to mess it up, don't mess it up. And so we have 16 times x is 16x. And then what's 16 times 8? That'd be 128. Minus 18 times 2. Is that 162? Then a negative times a negative is a positive. Oh man, why do we make these so long? Mr. Nyson, this is e-learning. We're not back at class. You don't have to make them so tough. But we don't want anybody to be smarter than you. We want to make sure that you are top of your game. Remember, some great basketball coach said, when you stop practicing, someone out there is still practicing. And when you meet up with them, they will win. And so there ain't nobody practicing harder than we are. And so we want to also practice efficiently. A negative times a negative is a positive. And so 11 times that would be 220. Right? I'm pretty sure. And then over here we have our 168. I got a little space before I have to write on my face. Minus 9x. But then this is going to be plus. And what is that? 152? No. It'd be 162. 7 times 63. Yes. Sometimes it's just too early in the morning. It's 153. What am I thinking? 9 times 7 is 63. I knew. It's just like, why did I have it end in a 2? That was not good. And so we're going to combine like terms. I guess Mondays on the videos are kind of rough. And so 16 plus 18 is 34 minus 20. It'll be a miracle if this video gets made without any mistakes. That'd be 14x, I think. And then I have 220 minus 128 minus 162, which is 70. Negative 70, yeah, because that makes negative 290. See, once I lose my confidence, then it's like you start doubting yourself. Happens to some of you also. And then 168 plus 153 would be 321 takeoff. And so 321, and this is going to be minus 9x. So if they subtract, we add. So that'd be 23x. And then that will equal 391. And the answer is, I am 16 going on 17. Doo -doo 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 -doo. That was the first song I ever accompanied one of my students on ISMA. She wanted to sing it for ISMA, and she said, Mr. Nyson, will you play the song for me? And I was honored, and I did. I am 16. She sounded much better than that. And so that one's 17. Okay? So there is the last couple notes. So get a piece of paper out, and I'm going to give you some hints. Some of you don't watch the videos to the end, and then you email me, I don't know how to do this one. Oh, I guess it was on the video. Maybe I should watch it to the end. Okay, so here we go. Get the homework out. If you get to the homework page, if I find it here, Here we go. You will notice that it says when you go down to do the written exercises, it'll say for problem 1 to 4, go up to do the oral exercises. So here is problem 3. But then down here is problem 6. And then problem 9. And problem 12. So problem 3 is up here. And then go down to problem 6, 9, 12, 15, 18, and so on. So the first problem, you copy it on your homework. And then multiply both sides by, what would we multiply by, Mason? 10. So we're going to multiply by 10. Don't you dare write in your book. And so here the 10s cancel and we'd get 3n. Here 10 divided by 5 is 2n. And here half of 10 is 5. And so 3n minus 2n is n, and n equals 5. You only have 10 more. That took me all about 5 seconds. And so when we skip down here to problem 6, guess what? It's almost the same problem, except there's a plus sign, and over here is 3/2 instead of 1/2. Problem number 9, don't forget to distribute the negative. Okay? And then when we get down to the harder ones, it says, see the samples. But for the last problems, if you look, and we assigned all the way to problem 33. Ooh. Why did we stop at 30, Mr. Nyson? But like, let's give you a few hints. Like 30, you're going to multiply by 12. And on 30, if you multiply by 12, it's just that first step. 3/4 of 12 is 9. So it's going to be 9 times x minus 2. And then 2/3 of 12 is 8. And that's going to be 8 times x minus half. Well, you can just distribute that because half of 8 is 4. That's no biggie. And a negative times a negative is a positive. And over here, half of 12 is 6. And this is going to be 6 times the quantity x plus 1. So that's going to be your first line of problem 30, and that shouldn't be too tough. Problem 27, you can actually cancel the 3's right away. And then you only have to multiply by 4 instead of multiplying by 12. And if you do that and you multiply both sides by 4, over here the 4's cancel. And I'm just going to write it right here. You get 6x plus 7. And on this side, half of 4 is 2. So you get 2 times the quantity of 2x plus 5. And then here, you get 4 times x, which is minus 4x. And you should be able to finish it from there. Distribute the 2, combine like terms, and solve it. Now, problem 33. Even though we're e-learning and distance apart, there goes Mingo, we want to still do the harder problems. It says solve for x in terms of the other letter. Well, in problem 33, you would factor the top. And this would be m plus 5 times the quantity of m plus 5. And so you got it squared. On this side, you have m times m plus 5. If you pull out an m and factor it. And then if you put this over 2x, you could cancel one of the m plus 5's on both sides. Put this over 1 and cross multiply. And when you cross multiply, multiplication is commutative. So really all you got to do is switch these spots. And so if the 2x goes up here, and the m goes on the bottom, you would get m plus 5 over m, which would equal 2x. But you can divide by 2. And it said solve for x, so I believe the answer would be m plus 5 over 2m if I didn't make a mistake. So hopefully there are no mistakes. And some of these, oh look, problem 24, we'll give you another one. On problem 24, you're multiplying by 20. So when you multiply both sides by 20, you get 20h minus 5 times the quantity of h plus 1. And make sure you distribute a negative 5. And over here, you're going to get 20 divided by 5 is 4 times the quantity of 2h plus 3, which would be 8h plus 12. But then don't forget to take this 20 times the 1, which you get plus 20. Okay? So that's your first step on 24, and that should be very helpful. So, hey, we got another week of this, and so we miss all you guys, and so it's good to see the classroom, and so we do miss you, and try to get that homework sent in right away. Work on your logic problems, and if you want to do the academic Super Bowl competition, you'll get more information soon. And so thank you, and keep up the great work, all of you, and we miss all of you. So, hey, have a great day.